Welcome back to Cyber in Practice. In this episode, we're going hands-on with Windows Defender Firewall to see how security administrators control network communications and validate security controls through testing. We'll establish a baseline connection, analyze network visibility using Nmap, implement a firewall rule to block ICMP traffic, and then validate that the policy is working as intended. Most importantly, we'll examine how simple firewall rules can directly impact what systems can see and communicate with across a network. Before we begin the demonstration, let's review the core concepts behind firewall technology. What is a firewall? A firewall acts as a security gatekeeper between systems and networks. Its job is to inspect network traffic and determine whether communication should be allowed or blocked based on the predefined security policies. From a defensive security perspective, firewalls provide traffic filtering, access control, and visibility into network activity and consistent enforcement of security requirements. Whether protecting a single workstation or an entire environment, firewalls remain one of the most important foundation security controls. Understanding what a firewall does is important, but it's equally important to understand why properly configured firewall rules matters. Why firewall rules matters. Without properly configured firewall rules, systems can become unnecessarily exposed to the network. Open services may be reachable by unauthorized access users. Attackers can gather information through scanning activities, and compromised systems may be able to move laterally throughout an environment. Firewall rules help reduce attack surfaces by limiting communication to only what is required for business operations. This principle of restricting unnecessary access is a core component of modern cybersecurity defense strategy. Now let's review some of the technical concepts we'll encounter during today's demonstration. Throughout this exercise, you'll hear several important terms. We'll be working with firewall rules, inbound traffic filtering, policy enforcement, and validation testing. We'll also use ICMP Echo Requests, commonly known as ping traffic, to test connectivity between systems. To analyze network visibility, we'll use Nmap, a popular network scanning tool that identifies reachable hosts and available services. Together, these technologies help administrators understand network exposure and verify that security controls are functioning correctly. With those concepts established, let's look at what we'll accomplish during this demonstration. Our objectives are straightforward. First, we'll establish baseline connectivity between two systems. Next, we'll perform a network scan to identify available services. We'll then create and enable a Windows Defender Firewall rule designed to block ICMP Echo Requests. After applying the control, we'll validate its effectiveness through additional testing and compare the before and after results. This process mirrors how security teams deploy and verify defensive controls in real-world environments. Let's take a quick look at the lab environment we'll be using. For this demonstration, we'll be working in a Kali Linux virtual machine and a Windows 11 virtual machine connected through an internal virtual network. Kali will be used to perform connectivity testing and network scanning, while Windows Defender Firewall will serve as the security control. The process will follow a structured workflow: verify connectivity, perform scanning, implement a firewall rule, validate enforcement, and compare the results. With that foundation in place, let's move into the live demonstration. To begin, I log into Kali Linux virtual machine. Before making any security changes, it's important to establish a baseline. The baseline measurement allows us to understand the current state of the environment so we can accurately evaluate the impacts of the modifications. I'll start by testing connectivity between the Kali Linux system and a Windows workstation. As we can see, communication is successful and the Windows system is responded as expected. This confirms that network traffic is currently being permitted and provides a baseline that we'll compare against after implementing our firewall rule. Now that we verified connectivity, let's examine the services currently exposed on the Windows system. Next, I'll perform a network scan to evaluate the Windows system current network exposure. Network scanning helps security professionals identify reachable hosts, discover available services, and understand what information is visible across the network. Reviewing these results gives us a baseline view of a system before any firewall changes are made. We'll use the baseline later to compare the impact of security controls we're about to implement. With our baseline documented, let's move on to the Windows systems and implement a security control. On the Windows virtual machine, I'll open Windows Defender Firewall with advanced security. Windows Defender Firewall allows administrators to create and manage inbound and outbound filtering rules that control the network communications. These rules determine what traffic is allowed into or out of the system and help enforce organizational security policies. In this case, We'll create a rule specifically designed to block ICMP Echo Requests. Let's create that rule now. Next, I'll create a new inbound firewall rule designed to restrict a specific type of network traffic. In this case, a rule targets ICMP Echo Requests, which are commonly used to test connectivity and determine whether a system is reachable on the network. While ICMP serves legitimate administrative purposes, many organizations choose to limit these responses to reduce network visibility and make reconnaissance activities more difficult for potential attackers. As the rule is configured, we're defining how the system should handle this traffic and implement a security control that aligns with organization's network security policies. Once the rule is applied, we'll test the environment again to determine whether the control is functioning as intended. With the rule now configured, let's verify that the policy is being enforced and examine the impact on the network visibility. The firewall rule has been created and enabled. At this point, the policy is actively being enforced by Windows Defender Firewall. This is an important distinction because creating a rule alone isn't enough. Security administrators must ensure that the controls are actually enabled and operational. Now comes the most important part of the process, validation. Let's return to Kali Linux and verify whether the new security controls is working as expected. Now that the firewall rule has been applied, let's test the environment again to see whether our security controls is having the intended effect. From the Kali system, I'll perform the same connectivity check we used during the baseline assessment. Notice the difference this time? The traffic is no longer receiving a response from the Windows system. This change demonstrates that the firewall policy is actively enforcing the rule we configured. The system remains operational and connected to the network, but specific traffic is now being restricted according to security policies. This type of validation is important because it confirms that the security control is not only configured, but also functioning as expected in a real environment. Now that we've confirmed the policy enforcement, let's take another look at the network and compare the results against our original baseline. With the firewall rule now in place, let's perform another network scan and compare the results to our original baseline. The purpose of this scan is to evaluate whether security controls has changed how the Windows system appears from the network's perspective. As we review the results, notice that network visibility has changed following the implementation of the firewall rule. Restricting ICMP traffic affects how the system responds to certain types of network communication and can limit the information available during reconnaissance activities. This highlights why validation testing is such an important part of security operations. Configuring a control is only the first step. Security teams must verify that policies are being enforced and producing the intended security outcome. By comparing our baseline results to our post-implementation results, we can clearly see the impact of the firewall rule and confirm that the control is working as expected. Now that we validated the controls, let's summarize the key observations from today's demonstration. During the testing baseline, connectivity was successfully established between the Kali Linux and Windows systems. The initial Nmap scan identified reachable services and confirmed network visibility. A Network Defender Firewall inbound rule was then created to block ICMP Echo Requests. Validation testing demonstrated that ping traffic was no longer permitted after the rules were enabled. Comparing the before and after results show reduced network visibility from the Kali system, confirming that the firewall successfully enforced the configured security policy. This is exactly the type of validation process security administrations use when implementing and verifying network security controls. Now let's connect what we just completed to the overall firewall management workflow. The process we follow mirrors the standard firewall management workflow. We begin by establishing a baseline to understand the current connectivity state. Next, we analyze network traffic through scanning and service emulation. After identifying the existing exposure, we applied the firewall rule and enabled policy enforcement. Finally, we validated the results through testing and compared them against our original baseline. This structured approach helps ensure that security controls are implemented correctly and verified through evidence-based testing. Firewalls play a critical role in controlling network communications and enforcing security policies. Network scanning helps administrators identify exposed services and understand system visibility. Firewall rules reduce attack surfaces by restricting unnecessary communication and limiting opportunities for reconnaissance. Most important, security controls must always be validated through testing to confirm they are functioning as intended. Whether managing a small environment or a large enterprise network, continuous review and verification of firewall policies helps strengthen that organization's overall security posture.
Thank you for watching Cyber in Practice. If you enjoyed this demonstration, stay tuned for future Cyber in Practice episodes.